So thank you guys for coming out tonight. So today we're going to be covering web security. It's just an overview. I'm not teaching you how to hack. I'm just teaching you about why the internet is a mess. Why the internet security is a mess. So let's get started with announcements. So Checkpoint 2 is due this Friday. So that's 4 days from now. So you guys are only working on the authorization microservice and its Docker file. We will be using the Docker file to run your code in the AutoGrader. So make sure that you, I believe, yeah. So make sure you understand what's going on. I think we do give you this Docker file, so you don't have to worry about it. Also, we ran into a few errors during office hours and in previous Piazza posts. So if you have not pulled as of like 6:15 p.m. today, please pull the latest changes. They won't break your code, but there's like some minor issues with running it. So I highly recommend that you guys do that. How should we test your code? I believe there's a Piazza post on that. I will get to that, I think after lecture or maybe later today. Generally testing, you just use Insomnia, but I digress. We'll probably release a lecture on that. Sorry, not a lecture. We'll release a Piazza post on that. So there was a lecture where we covered a bit of debugging, but I'll show you guys another way to do it using Python and Insomnia together. Anyways, AWS Educate, please do not create any services just yet. If you do end up using it for other purposes and you run out of credits, we can't guarantee that you'll be getting more for this class. So just sit tight on AWS. One of our core staff is working on setting all that up. And yeah. Do we have slip days? We don't have official slip days, but if you feel like you need an extension or you're just overwhelmed, just make a private Piazza post, and we'll talk. Like we've given multiple extensions already. We're pretty generous with that. We're just hoping that no one abuses it. So yeah, no official slip days, but if you're running into trouble, just let us know. So last time we did the code base walkthrough. We covered the different microservices, so authorization posts and etc. So you guys will be working on authorization. And question on backing up your code. You don't have to back up your code before you pull. If you do run into merge conflicts, please make a private Piazza post. But generally, you shouldn't be running into merge conflicts because we didn't change anything drastic. So just to get pull source master. But yeah. Okay, so then before the code base walkthrough, we covered microservices. And you guys should be very familiar with that. You guys did an assignment on it. You guys turned it in. But yeah, today we're going to be covering the introduction to web security and just the fundamentals. You guys won't be hacking the NSA after this lecture, unfortunately, or fortunately. So when we talk about the beginning of the internet and why the security of the internet is actually a complete mess, we'll talk about web pages, so what they're comprised of, HTML, CSS, and JavaScript, JavaScript being the most important one. And we'll cover cookies and frames. Yeah, and then after frames, we'll cover the same origin policy. I'm not sure if I included cookies in this lecture, but we'll see. I think you guys are very familiar with cookies, but we'll talk about them in the context of JavaScript. Yeah, so beginning of the internet. So the problem when we didn't actually have the internet was that we needed some way for computers to communicate. So the solution was to create the concept of a network, have a network where computers can communicate. So that was what ARPANET was. So this was funded by the U.S. Department of Defense. It was just a way for people to share research papers. So scientists want to share research papers in a really fast way without using like letters and stuff. So they made the first workable prototype of the internet. So this allowed multiple computers to communicate on a single network. So the first login, so the first message ever sent on the first workable prototype of the internet was login, which was sent from UCLA to Stanford. And this ended up crashing the network. And Stanford only ended up receiving the first two letters. If they had Berkeley students working on it, it probably would have worked a lot better, but that's besides the point. So you can see like this is a logical map of what ARPANET is. You'll probably be able to find like the NSA. You see Stanford here on the left side. You should probably find UCLA somewhere. But this is what the internet looked like in its first ever revision. First ever working revision, or mostly working revision. But yeah, you guys can stare at this if you want to. You guys have access to the slides, I think. Yeah, but yeah, so let's cover why the internet security is a mess. So the most important principle of security, if you've taken 161, or one of the most important ones, is you need to build security in to a system from the start. And because the internet back then, because ARPANET wasn't meant for global usage, there wasn't really any security concerns. So security was not built in from the start. If you are a web developer, you probably know why and how much of a mess the ecosystem, the web development ecosystem is. So yeah. So problem is that we were only meant to share research papers, so you didn't have any security concerns, and very few people had access anyway, so there wasn't like any hacking going on, if at all. And everything else since then has been a hack or a patch, meaning we've always been building up new things on the first revision. We never really like started over and made the internet a very like complete whole where everything works perfectly. So if you're going into web development, please be prepared for lots and lots of pain and lots of hair pulling. I'm sure many of you have already had experience with it in your clubs or your other internship system or something like that. And yeah, maybe it is time for a new internet. You could be the next Richard Hendricks and make the new internet. So here's your obligatory Silicon Valley reference. And yeah, so let's talk about web pages. So this is what a web page looks like. We have our actual web page, which is our view, and we have the URL. So you can see https / whatever, google.com. So web page URLs are, well, URL stands for Uniform Resource Locator. They're divided into different sections. So you probably are very familiar with this. You probably know that HTTP is our protocol because we're sending HTTP requests. Generally, we send HTTPS requests, meaning that they're secure and unreadable by some kind of man-in-the-middle attacker. So if someone's snooping on your network and you're sending HTTP requests, they can sniff it. So they can actually see what you're sending. So yeah, it's better to use HTTPS requests, but we'll go into the logistics of that later on. We have our host name, which is just like our website name. We have the port, the path, which is just like the sub URL. And you're very familiar with query because that's what we do with query parameters. And recall that everything that we send through a browser is sent through HTTP requests. So it's built on top of a TCP connection. We establish connection, send the packet, and then close that connection. I know I'm a little, I glossed over this, but I'm only glossing over this because we've already covered it. So let's talk about the components of a web page. So we'll go into HTML, CSS, and JavaScript. So let's talk about HTML first. It stands for Hypertext Markup Language, and it's kind of like the LaTeX for web pages. Excuse me. If you're familiar with LaTeX, if you're not familiar with LaTeX, it's basically a way to just write things on a page. And I suggest you look it up. But essentially, HTML is where you basically write the content of your web page, and then it shows up in your web browser. CSS is cascading style sheets. It formats your HTML content. It's more of like aesthetics. It makes your website look pretty. And what our biggest concern is JavaScript, because it's a scripting language that can read and modify a web page and its elements. So here's what some HTML looks like. All it will do is name the tab, I believe, My First Web Page. And I'm not too familiar with HTML because I'm not a front-end web developer. But you'll have some header and then some paragraph where it says, my first web page, and this is a paragraph. This is what it looks like. We're not going to be concerning ourselves too much with this. It's just to give you an idea of what it looks like. How the web browser actually sees it is this document object model. So we have our root element, which is like our HTML. We'll also generally have some kind of, we'll have, so we have this, and it's split into its individual tags. So if we go back, this HTML tag at the top, anything within these arrows are tags. They're called tags, and each of these tags has their own little node in the document object model. And JavaScript can pretty much modify anything here, so we'll get into the security concerns about that. So yeah, concerns. We can change the images. We can hide and unhide elements. We can change what the cursor looks like, things like that. JavaScript is really, really powerful. And because of that, it's kind of a pain because JavaScript can pretty much modify anything. More problems in terms of cookies, it can read and modify the values. So let's say we set an insecure cookie on our web browser from, let's say, our Golang program. We set the cookie and it's insecure. The JavaScript would actually be able to read that, maybe send it somewhere else, and then delete it after it sent it somewhere else. So that would be a very, very bad situation because first, we don't want anyone to even see our access token, because it basically describes who we are as an entity in the eyes of a server. So it authenticates us. So if someone were to get our access token, they could do anything on the server and act as if it's us. So that's a really big problem. So yeah, cookies. So JavaScript can read them. So if you want to read it, you can just do var x equals dot. If you go into a web browser and you go into DevTools, you can actually like execute JavaScript. You could probably say console.log document.cookie, and it'll print out your cookie. You can probably write it. So here's some JavaScript to actually overwrite a cookie. So you can see how if an attacker were to have some access over our web page, it would be a problem if they could override our cookies and even read them, because that's just a huge problem. I'm not sure if we have time for a demo. I'll leave this toward the end, but our main concern is that we're not really too worried about HTML and CSS. Our biggest concern is JavaScript. So next we'll talk about frames, and JavaScript will appear later. Sorry if I'm rushing a little bit. I'm not sure if we can actually finish on time, depending on how fast we go, because I want to leave questions for the end. So frames, it's essentially an aspect of HTML where you can embed web pages within web pages. So you can see here how on the right side we have a web page, and then they somehow manage to embed gmail.com within that web page using this iframe tag. So this is what a frame looks like. Can anyone see any issues with this based on what we've covered so far? Just type in the chat or speak up if you'd like. We have essentially we have a web page within a web page. Do you think, let's see. Yes, good question. Does the outside or inside frames have access to the information in the other? So yes, if you have some kind of website where you just embed Gmail and then you had access to anything within that Gmail, that would be a huge problem, because anyone can set up a website, and as soon as you visit that website, it'll load your Gmail, and then JavaScript would be able to access it. Thankfully, we have ways to isolate iframes from each other and from the outer web page. So there's actually ways to make sure that, one, your website never actually runs in an iframe. There's ways to do that. I highly recommend you guys take 161 if you want to know about that. But yeah, fake login pages, good. You'll see a lot of that. Sometimes you'll see like fake login pages with your email. Invisible iframes, that would be really bad too. What if you have an iframe with this Gmail and then it was invisible, and you didn't even know they took your like cookie or access token or whatever. Security issues, yes. So we are, yes, an iframe on top of this iframe. Yeah, let's not try to mind bend ourselves too much, but essentially we want to make sure that there's some kind of separation or isolation. So iframes do actually take that into account. So what if JavaScript in one frame accesses the information of another? Because remember, JavaScript is a very powerful tool. So our solution is that the web browsers enforce frame isolation. So this is actually up to the web browser, I believe. So I believe if you decided to use like your own web browser, you would have to enforce the security protocols to make sure that you don't have your information stolen. So this brings us, actually we're very good on time. This brings us to the same origin policy. So the big idea is that an origin is like some aspect of a website, and if you have a different origin, you shouldn't be able to communicate, or you shouldn't be able to access the resources of a different origin. So this means that you want different web pages to be isolated from each other. So you don't want the information from google.com and facebook.com to communicate, because then facebook.com might be able to take your login information from google.com or things like that. And you want to make sure that different frames in a web page are isolated from each other. So like we talked about in the previous slide, iframes can be risky if the security aspects are not enforced. Thankfully, most, if not all, modern web browsers, enforce that security. So I want to let's define what origin is. So it's the combination of a protocol, hostname, and port. So when you have some kind of web browser, when it's trying to check if two things have the same origin, all it's doing is string matching. It takes the URL in its plain text and it does string matching. It looks for similarities in the protocol, similarities in the hostname, and similarities in the port. So let's actually get some practice with that. Just remember that protocol is like your HTTP or HTTPS. Hostname is pretty much the name of your website. Excuse me. And port is the port that it's running on. So let's do some practice. Do these two URLs originate from the same origin? So just type in chat, do these two URLs follow the same origin policy? So I see a no. Looks like they corrected to yes. Yes, I see a lot of yeses. Yeah, so they both run on the HTTP protocol. The name of the website is the same. And we don't know the port, but the default port is port 80. So yeah, so in this case, they do follow the same. They're from the same origin. Let's try another one. How about these two? So if you say yes, let's kind of like explain your thought process. If you think no, what's different about them? Like what's different about the origins? Okay, I see a bunch of no's. API dot subdomain, CalCloud does not equal API. Okay. No. Cool. Yeah, you guys got it. So because we have a subdomain, those technically do not originate from like the same host. So CalCloud and API.CalCloud are not the same. So even though the protocols and the ports are the exact same, because the host name is different, these are not from the same origin. So how do you control for large web pages where there are multiple ports it could originate from? Generally, you have on your web server, you have some kind of load balancer that's always the same port, and then it kind of forwards your request to different ports internally. I highly recommend, if you're more curious about that, I recommend you look into reverse proxies. Let's try another one. How about these two? So it looks like we have a no in the chat. No, there's a it says HTTP/HTTPS. Yeah, that seems to be a problem. They're not from the same protocol. Do you guys see any other issues with it? Different port. Yeah, one's running on port 80 and the second is running on port 81. Is there any other, is there any other concern, or is that the same? Yeah, I see CalCloud does not equal API.CalCloud. Yeah, perfect. You guys got it. So in this case, that's pretty much messed up in every way possible. The host name is different, the protocol is different, the port's different. So in this case, it's not from the same origin. All right, one last one before I try and go into the demo. Do these follow the same origin policy? I see is good. I see Gucci. I see a question mark yes. Any other answers? Yes, I see an exclamation point yes now. Yeah, you guys got it. So these two URLs do follow the same origin policy. Yeah, so I'm going to try and give a demo. Just give me one moment. If you guys have any questions right now, just toss them in the chat. Can they try and trick you using I and like capital L and or lowercase l and capital I? Yeah, that maybe I should have done that just to be a little more subtle. But yeah, and there's been issues where there's like Greek letters that are very, very similar to like English letters. So like if you have like a Greek letter that looks like P, you could create your own URL like with the P and then maybe like right PayPal or something. And something like that has actually happened where people have been scammed with fake PayPal links or fake eBay links. I'm not sure which one it was, but they do talk about it in CS 161. I am trying to pull up the yeah, they do look the same, like in the web browser. Let's see. Trying to find it. All right. I found it. Just give me one moment. Time for new share. Can you guys see this? Can you guys see this try it yourself editor? Cool. Let me actually pull up. Here's the demo. I believe this should run. So you can see, let me zoom in a little bit for you guys. So you can see here that we have a paragraph and we give it some unique identifier. Don't worry too much. You're not going to be tested on this or expected to know this. The ID, we're just giving this paragraph the ID number or ID tag of demo. And this paragraph, all it says is JavaScript can change HTML content. And as you can see on the right side, we have the actual plain text that's just outputted there because this is a paragraph. So we end the paragraph, then we create a button, and the what it does is on click, it executes some JavaScript where we get the element, we get some element by its ID, and then we change its inner HTML to something else. And then the buttons, we close that, and then we end it with naming the button Click Me. So you can see here, as soon as I click me, it changes the inner HTML of this paragraph to JavaScript. So you can imagine, like, you know, if there was like some theoretically like some really sophisticated attack where someone knows where you are and you go on their website and it's like, hey, change the text on this page to your cookie, and then, you know, their partner is like behind you, like writing down the cookie or whatever. That I'm just saying some example of like some very like, you know, far-fetched example of how people can execute these kinds of attacks. We'll be talking more about JavaScript attacks, like, you know, cross-site scripting and CSRF attacks, probably Tuesday. I don't know how in depth we're going to go since it's not particularly relevant to your project, but you can see, like, if I try and say, like, if I just change it just to be sure, like hello cloud right here, and then I change the actual text to, let's say, hello computing. And I want to say, you know, change the button name to change text. Let's run it. It says hello cloud here. The button's name is change text. As soon as I click it, it changes to hello computing. So you can see how it can read the different aspects of your website and it can change them. If I actually, let's see, if I just change, let me actually share my entire screen. Can you guys see the screen? It's just a bunch of HTML. Cool. So if I actually go into console, so this is Chrome DevTools. I think you can just, you know, right click, click inspect. You'll pull this up. And if you actually go here, you'll see like a bunch of stuff here you don't need to worry about. I think, can I clear? I don't know. But essentially, if I try to do document.cookie right here, it printed out the cookie. Now, I don't think that this is private information because I just opened it up in oh, you can't see my console. Oh, my bad. Sorry. Can you guys see the console now? Yeah, so it pulled, so when I clicked inspect, it pulled this up on the top. I clicked on console and I typed in document.cookie. So I'll just do it again, just to show you guys. And this is the cookie for this document. Let me hide these meeting controls. Cool. So you can see there's a bunch of settings here. And let's say that this was potentially sensitive information. It would be pretty bad. This is not sensitive information because I just, I opened it on an incognito window. Another way you can actually check your cookies is I believe under application, you can see all the different cookies here for different websites. So this so when I did console, it printed out a bunch of different cookies. So if I want to see them in a more like nice pattern, we can go here so you can see the different cookies that it's assigned. In theory, one of them will be called like for us, it's going to be called access token. And we're going to be setting it. So we're going to be setting it so that you can't even read it, because remember, the person that signs in never really needs to know what they're signed in for. They just need to know that they're signed in. So we will implement something within our project that only lets the browser see it and does not let any JavaScript touch it. It doesn't let any human read it. So you'll see that. For debugging purposes, initially we will say that you can look at it. So you'll go under application. Once we've released the front end, you can go to application. You can see the access token, and yeah. Is there any way of telling what the cookie is doing? Not really, unless you know like the protocol that they use. Like if I were to just look at this, I would say this is probably some base64 encoding. Maybe I'll go into a decoder and try and see what that is. But essentially, normally you'd never be able to see a cookie if it's private, because the web browser enforces it in case that it's meant to be private. And we'll go into that. But this is just a way for you guys to see like what kind of cookies there are. If I were to do like document.cookie is equal to this, if I do document.cookie again, you can, let's see, I guess it's not modifiable, but generally you'd be able to modify it. I'm not exactly sure on how to modify it. Maybe there's like a modification protection, but yeah, that would be one way you could potentially modify the cookie. And that's what malicious attackers are going to try and do. They're going to try and read your cookie, send it to someone else, or send it to themselves on a different platform, and then try and delete it or something like that, so that you're logged out and now they're logged in as you. So you can see a little, this is just like a little taste and a glimpse of the stuff you would learn in 161. But yeah, I think that is it for this lecture, actually. One sec, let me share again. Let's see, where's the PowerPoint slideshow? So we'll be talking more about the, can you guys see the slides? Yeah, so we're going to be talking more about the same origin policy and things like that. We're going to different kinds of cross-site scripting attacks or XSS attacks. If you guys want to look it up, feel free to do so. But for now, we're just we're going to stop at same origin. Just make sure like you understand what it means for two websites to be from the same origin. Make sure you understand like the different things that your browser enforces, where it isolates different websites and it isolates different iframes. And if you're actually curious, there is a way for iframes to talk to the outer website. There's a very, very specific JavaScript API to do that. It's like post message and read message or something like that. I'm not particularly sure, but it's a very, very narrow API with only like, maybe like 2 to 4 functions or 2 to 4 like main functions that let you actually communicate between iframes or different websites. So if you're curious, just look into that. But other than that, I think I didn't even need to worry about time. You guys are free to go or stick around for questions. But yeah, hope you guys enjoyed this introduction to web security, and you guys probably understand why the internet and web development is such a mess, because there's so many different aspects to it and so many different vulnerabilities. And if ARPANET actually thought of implementing security, we probably wouldn't be here right now, where coding in JavaScript is a pain, but we make do. So yeah, I'll stick around for questions for maybe like 10 more minutes. Yeah, let me go back to the same origin policy info slide. Here we go. This is just a protocol, hostname, and port. So Gia, are these slides on the website yet?
Yes, they should. If they aren't, they should be now.
Okay, cool. So there's a question in the chat. For the same origin policy, what happens when there are multiple domain names for one website? are they just considered different origins? Could you elaborate on domain names? Like, are you talking about like, when you type something in and then you redirect to a different page? Yeah, I believe the redirection happens between a server, so it doesn't actually like send you any information. So I think you would only like think about the one that the website that you redirected to. There would technically be different origins if they don't have the exact same website name, which you can assume they don't because one's redirecting to the other. But it's normally not an issue because you're always seeing like one website and you're only really using one. Yeah. So looks like there's a few logistical questions for the project. How should we do testing? Generally just use Insomnia. If you can sign up, you can register. If you can sign up, sign in, and log out, those are the big three that we're going to be assigning points for. Yeah, if you can do those three, then you should be fine. So to test that, you would just send HTTP requests over Insomnia. To actually run it, you make sure to pull the latest changes. And then run build.sh. And make sure another issue, make sure you have Docker installed because build.sh depends on Docker. In the required software thread, there's instructions. If you're a Windows user, make sure to download Windows 10 Education from our Cal software catalog. It's free. But yeah, we'll be releasing some tests for you just so that you guys can like test locally. So these are going to be pretty much the exact same ones, if not the exact same ones that we run in the autograder. So that way you guys don't spam the autograder. Where's the LinkedIn workshop recording? Unfortunately, Ismail requested that we don't keep the recording because it's proprietary. That way he doesn't want his content going out for free because he wants to make use of his talents in the future. So unfortunately, we can't do the recording. I believe he did send over a link to the slides where you have to manually request access. So I'll send that out in a Piazza post. Will the autograder have hidden tests or infinite submissions? No, we're completely transparent. We don't do hidden tests. I personally hate hidden tests because it's better to just have feedback. That's what I believe. Infinite submissions, yes, but please don't spam the autograder because we're going to be sending out like a file, like a Python file or something or a Golang file that lets you actually run the test yourselves. Yes, in the Piazza post, I did mention you need to implement Dockerfile since I forgot that that's one of the ones that we give to you guys. So you guys do not have to finish the Dockerfile for odd service because it's already done for you. And no, there is not going to be whatever 61C status means. We're very transparent on the autograder. Yeah, so are there any good resources or tutorials to self-learn HTML, CSS, and JavaScript? I heard this link that I just did the demo on is actually very useful. So W3 Schools, MDN Docs, I believe that's the Mozilla something documentation. You can look into that too. I won't be making a post for it personally because we're in HTML and CSS and even JavaScript is not the focus. Yeah. Future autograders require that we run our code through using the Docker image. How do we do that? Let's see. I believe we did a lecture on Docker, so feel free to reference that demo. The demo is exactly how you're expected to be able to run your code. So make sure you have Docker installed. Go through the Docker lecture. I showed you guys an example of how to compile a Hello World program. The commands to run it are pretty much the exact same thing. And yeah, is testing through Docker any different as using Insomnia? It's a little hard to answer that question because Docker is just what runs our program. Like if we run our program on Docker, it should be the exact same thing as if we're running the web server, like with Go run main.go. So Insomnia is the one that actually does the testing. So if we were to actually run Docker, or run our program on Docker, so in a container versus running it in, the local host like Go run main.go, it would be the exact same thing. So if you're sending requests to one, you'd be sending requests to the other. They're pretty much interchangeable. The reason we enforce Docker is because of containerization being a very big topic. we want you guys to be familiar. So even if in this specific context, you may not want to like build the image every single time. We want, in terms of submission, we are going to be running the Docker file and using that to run your code. Yeah, Docker is just a black box. You spin something up, you have the contract, which is all the routes you defined, and anything that goes to those routes will get something back. And we have those explicitly defined in the spec and within the comments. Yeah. All right. So I'll say stick around for like maybe 2 to 3 more minutes in case there's questions, but you guys are free to go. Thank you guys for coming out and staying the entire time. Have a good one. All right. Since there's no further questions, I'll just end the meeting. You guys have a great week. See you guys Thursday.